Hey everybody, I'm meteorologist Gavin Sandel. Last week we saw the world's sixth strongest recorded earthquake off of Russia as an 8.8. Today's focus though is earthquakes away from the norm off of major hotbeds, and we're looking more towards the East Coast because in 3 days, 2 earthquakes hit the New York area far from any plate or earthquake zone, including today as a 2.7. So to understand why, let's see how earthquakes happen, and that goes to the discussion of tectonic plates. And when you have your top layer of the earth, that's called the earth's crust, you have plates that are on there. It's not just one even layer. There are multiple boundaries that can cause earthquakes. So in our neck of the woods, what we typically hear about is earthquakes in the Pacific. That comes from the convergence of the Pacific plate with the North American plate, which is why you see a lot of minor earthquakes in the last week. But in our area, we're right in the middle of the North American plate, but there are still some isolated earthquakes that do happen. So there has to be something behind what happens in the East Coast. So let's give you a background on how just earthquakes happen on plate boundaries. You have one plate here, a second plate here, and what it does is these plates rub together and it causes stress in the ground. You can see by those arrows right here. What ends up happening after that, the stress builds, it just little by little gets up until something has to happen. The stress needs to get relieved. When that gets relieved, the plates scrape all around each other, and there's a fracture. So when there's more energy than resistance, the plates fracture and vibrate among each other. And when there's more energy that's broken, then that's when you have stronger earthquakes in the area. So that's how you got that 8.8 earthquake last week. That was so much energy that was just built up waiting to happen. So there's a couple of differences in East Coast plate tectonics and geology versus West Coast geology. So in the East Coast, the rock is harder and denser, and what that means is when earthquakes happen, it's much easier for things to travel. So if you have an earthquake of one size, it's much easier for those waves to travel across the land. And faults as well are a big thing on the West Coast. There's no active faults here on the East Coast because we're in the middle of a plate. Also here, structures are not very earthquake resilient. So when you do have an earthquake, there are major impacts. So here's a look. I'm comparing 2 earthquakes now to decipher what the difference is between something on the East Coast versus the West Coast is. So this is actually a very major earthquake that happened. This was 14 years ago in the summer of 2011. I personally remember this one. This happened in central Virginia. It was a 5.8. The entire area shaded in red was able to feel this earthquake. And now compared to an earthquake that occurred in 2004, this is a 6.0, actually a little stronger on the Richter scale. But look at how small of an area, just about the middle third and going along the coast of California. That's pretty impressive numbers and goes to show that earthquakes are much easier to be felt along the East Coast. But that still gets rid of the question, or that still begs the question, how can earthquakes happen away from major faults? And while there aren't any active faults in our area, there are inactive faults across the eastern United States, and there could be ways to really get them going. One thing, glaciers. There was a lot of glaciers in our area thousands of years ago from the Ice Age, and we're still rebounding. The crust is still going upward, and this could cause faults to occur. Human-induced impacts as well. Youngstown was a very popular area in 2011 due to earthquakes. There had not been an earthquake since 1776 in Youngstown, and there suddenly happened to be 190 earthquakes, in our area. That was because of human-induced causes. So there's a lot of reasons why it could happen across the East Coast, but when it does, it is a very interesting thing to see. Well, with that, I'm meteorologist Gavin Sandel, hoping for no more earthquakes in our area.